Hi gents, we're going to start a new section today and it's called Conditions of Equilibrium. So right now I'm on page 60 of our Unit 1 booklet. So basically we know an equilibrium system of concurrent forces is that a force which when added to the system produces equilibrium. So we've got our little diagram here of our force system. And we know when something is in equilibrium that all our arrows should be going in a direction. Okay, there shouldn't be any clashes with our arrows. Remember we learnt resultants last time, and resultants will show that an arrow should clash on our free body diagram. So let's have a look at exercise 1 and we'll have a little go. So right now I'm on page 62 for this. This is exercise 1. It looks like this. Okay. It says find the force in member 1 and 2 of the framework below, graphically and mathematically. Now for this video, I'm only going to show you mathematically. You have to watch the next one for graphically. Okay. Now I've done a little replica again so we can see it a bit clearly. Exercise 1, we've got a vertical force pushing down at 500 newtons. We're finding 1 and 2 and they've given us a 30 degree angle. Now I've written down a couple of steps we should always follow. So the first one is, when we have a problem mathematically, we need to do a free body diagram first. So that way we can really see what's going on. So we'll do our first one. So use the information they give you first. So we'll start with a free body diagram. Okay. Our first arrow is going down, so place that in, 500 newtons. So this free body diagram takes away this truss just so we can see it in arrows, okay? Just see all our forces. Now we've learnt trusses, so we understand when two forces are pushing together, it's under compression. So this one here, we would take a guess and we would say that is most likely under compression, that one. If they're pushing together, well that one's pushing away, so that number 1 is most likely in tension. Okay? So we'll put that down as 1, this one here is 2. Okay? Now we can't put that 30 degrees in here, but we know from this triangle that that's a 90 degree angle, that's 30 degrees, so that one there has to be 60 degrees, and we can place that in. Okay? That's good. So that's our free body diagram done. You can give that a little tick. The next step is draw a triangular shape. Now I say triangular shape because right now we have 3 forces. 3 forces allows us to draw a triangle, okay, because there's only 3. If we had more than 3 forces, so 4, 5, 6 forces, well then it would just be a shape that would make an equilibrium. So we have 3 right now, so we can draw a triangle. So we just start with our first one. I'll do this in red. So our arrow's going down. Okay. This one's going horizontal. So wherever that arrow ends, that's where we're leaving from. So we draw across with another arrow. Good. And this arrow is going up, but we start from here. So we're placing that up. Okay, something like that, right? Add in our little part. So we got 500 newtons. We know that one there was 1, okay, that one there was 2, okay. Now if we bring this across and move this up into there, we know over here is 60 degrees, so that one there must be 30 degrees. And down in here is the 60 degrees that we were looking at before, okay. So when we start to work this out, this is the one we're going to use, obviously, the 60 degrees. So, we give that a bit of a tick, because we've just done that. Now we want to do some working. Now, because this is just a triangle, we don't need to use force horizontal, force vertical. We can if we wanted to, but for this we can just use sine, cos or tan depending on what we need to work out. So for our first one, our number 2, I could use sine for this. So let's have a go and show some working. So we would have sine 60 degrees is equal to 500 newtons over number 2. Okay, we need to isolate number 2. So isolate number 2 is equal to 500 over sine 60. Okay, and that gives us an answer of 2 is equal to 574.4 newtons. And you can write that straight up there. So you know that number 2 is 574.4 newtons. Okay, so we've found number 2 now, and that's what our question said. Find number 1 and 2. Now we need to find number 1. So let's have a go. So I'm going to use cos for this. So cos 60 again, okay, is equal to number 1 over, okay, number 1 over, and it's this one here, our hypotenuse. So 77.4, get number 1 by itself, so number 1 is equal to 577.4 cos 60. Okay, number 1's by itself. Okay, so number 1's answer is 288.7 newtons. You can add that up on the chart again, 288.7 newtons. Okay, so the question asked us, find forces member 1 and 2 in the framework below, and we've just found that. So there's our 2 answers for this. So that there, gents, is mathematically. Watch the next video to do it graphically.